And so the end of PowerPoint decided to crash in the middle of that last video. So just to pick up where we were, we can see that this ketone gets reduced into an alcohol just like it did when we saw the reaction with sodium borohydride. Now a very, very similar reaction to this is what's known as a Grignard addition. And most likely, probably around this time, you may be doing a Grignard reaction in the lab. Grignard reactions have two parts to them. One is making the Grignard reagent. Grignard reagents are inherently unstable, and so you typically have to make them right before you use them. So that's step one. And the way that we do that is we take an alkyl halide, most commonly a bromide, and you add magnesium to it. And the magnesium does what's known as an insertion reaction, where the magnesium just sticks itself right between the carbon and the bromine. So magnesium, being a metal, we know has very low electronegativity. And so Grignard reagents have partial negatives on both the carbon as well as the halogen, and a partial minus on magnesium. And that makes them really, really good nucleophiles. In fact, this RMGBr basically behaves as if it's R minus. And so these are able to add, once we make them, to aldehydes and ketones in the exact same way that the H minus did. So we've made our Grignard. Grignards are also excellent nucleophiles. And so the Grignard does nucleophilic attack onto the carbon of the carbonyl. And then we can finish the reaction by quenching with acid to give us an alcohol. So the nice thing about Grignard reagents, in some ways even better than the reduction reaction, is we still get the conversion of the carbonyl to an alcohol, but in addition, we were able to form and add more carbons to it as well. Now, Grignard reactions are, typically very, very useful reactions, work very well. But a couple of things we have to be careful about, and since this is something we're going to probably be doing in the lab, a couple of things to keep in mind. Grignard reagents are highly air and water sensitive. So you'll notice when we set up our apparatus for this, it'll be sealed on one end with a septum, and then on the other end you're going to have a drying tube containing a drying agent in it. And that's to keep water from getting into the reaction. A lot of organic reactions just don't like water. And so what happens if you take your Grignard reagent and it comes in the presence of water? Well, water is a good enough base, good enough electrophile, that the Grignard will just attack it, and you'll end up just making an alkane. The other thing that you need to be careful of with Grignards is you could never make a Grignard reagent that has a good electrophile in it. Again, Grignards are highly reactive. And so if you've already got an electrophile within the molecule, as soon as you make that Grignard, it's going to react with that electrophile. So these are two new ways of making alcohols that we add to the previous methods that we've learned. And from here, I'm going to end this video here. We're going to start discussing what we can do once we've already made an alcohol.